We have with us our resource person, Dr. Mamilla Ravishankar, working as Associate Professor in the Department of Mechanical Engineering at Indian Institute of Technology, Tirupati. And now I call Professor Vinod Raj to introduce the resource person to the audience.
Good morning, everyone.
Is my screen visible? No.
Yeah, sir.
Visible, na?
Yes, visual.
Oh, fine. Thank you.
Good morning, everyone. Dr. Mamilla Ravishankar is currently an associate professor in the Department of Mechanical Engineering, IIT Tirupati. Prior to this, he worked as an assistant professor in IIT Guwahati. He did his BTech from Sri Venkateswara University, Tirupati, and MTech as well as PhD from IIT Kanpur. His research group focuses on micro-nano manufacturing, sustainable manufacturing, precision 3D printing, online monitoring, biomanufacturing, coatings, tribology, and rheology. His lab also involves in development of lab-scale innovations to commercial manufacturing products. He has published over 60 internationally reputed journals, 100 international conferences, 6 patents, 2 edited books, and more than 10 book chapters. The knowledge transfer of his patent is already transferred to India's leading research laboratory such as CMTI Bangalore. Presently, his lab possesses with various fundings from BARC, DST, DRTO, MEITY, BARC, SIR, Imprint, IIT Guwahati, IIT Tirupati of about 4 crore rupees as a principal investigator and more than 75 crore rupees as a co-investigator. He guided 5 PhD, 25 MTech, and 30 BTech candidates. At present, guiding 10 PhD students, 4 MS research, and 5 MTech students. Currently, he is a reviewer of over 10 technical journals from Nature, Elsevier, ACS, Springer, Wiley, Ender Science, and Search publishers. He is the editorial member of IMEC Journal of Micro Manufacturing and a guest editor for International Journal of Precision Technology. He is a recipient of prestigious awards such as Institution of Engineers India, Young Engineers Award 2015 in Production Engineering, Indian Society for Advancement in Materials and Process Engineering 2011, and a finalist of an Indian National Academy of Engineering, Young Engineering Award 2014. He and his students received 3 Best Papers awards in national and international conferences. His students got 3 Best Poster awards in national and international conferences. Apart from academic awards, he also received an Institute's Blue Outstanding Sports Personality of IIT Kanpur for his games and sports achievement. We are fortunate to have such a distinguished person with us today. Thank you.
Now I invite Dr. Mamilla Ravishankar, Associate Professor, Department of Mechanical Engineering, Indian Institute of Technology, Tirupati, to take over the session. Over to Dr. Mamilla Ravishankar.
Thank you, Professor. Am I audible?
Yes, sir.
Yeah. Thank you for the kind introduction and the fraternity of the Institute for inviting me to deliver the talk. So, since it is on 3D printing technologies, so 3D printing technologies nowadays is one of the buzzwords. Most of the people are talking about always, they talk, I'm working in 3D printing and I'm working in 3D printing by procuring a 3D printing machines. So, but the real fact is that what you are working. So what you are working is you have purchased a commercial system and you are just building a component and you put into your showcase and you say that I am a 3D printing guy and other things. That is not the right way, because the second thing is that they will change one material and they try to print. Third thing that they try to do is just they will change the input parameters and they try to check what are the defects. Partially okay. So if you are doing, for example, if you purchase a world-based systems like EOS or SLM or any 3D systems, or many companies are there In India also we have, if you think 3D printing is going to be one of the economic processes, because when I am discussing with respect to the Indian vendors, I am talking about Indian vendors, almost all 6 people are in the market to supply, starting from Intech Additive, some I think yes, BFW, and so on. Many people are there. Okay, as per my understanding, when we quoted the machine, tendered the machine, almost all like 4 to 5 Indian vendors participated. Okay, so that means that India has a great future in terms of building the 3D printing machines. And I'm sure if those people who are planning for purchasing a 3D printer, just I request you to wait for another 1 year. If you can wait, a commercial systems from Indian vendors is going to come. Already Indian vendors are supplying, but there are limited vendors. So what is happening is they are also quoting the tender price as per as the international tenders. Because like, for example, if they are quoting 3 crores, these people are quoting 2.8 or something. So once this competition goes big, like if we take like 1 year or something, these people will start competing each other in Indian market itself. So you can get a 3D printing machine, I mean to say the starting level of 150 by 150 by 100 or something, you can get in a price of 60 to 90 lakhs rupees. Current price, for example, if you go to a 3D system or EOS system or SLM system, it will cross 1 crore. You can negotiate, that is obviously is there. Now you purchase a machine. So what are the research that you can do? The first and foremost research that you can do is, the best to the best of knowledge that you can do is varying the parameters and checking the quality of the product. But this particular product is not practically feasible because you don't have post-processing technologies first. However, you can do some up to certain things like defects in additive manufacturing. All people started reading in what are the defects in welding processes, defects in casting processes, and defect in casting processes you can correlate to 3D printing, and you can do some of the research. This is second research that you can do if you have a metal 3D printer or something. And if you have still more money, the third research that you can do is you can purchase a software called multipool analysis and other things. So that system also you can procure, multipool analysis, thermal analysis. These softwares are nowadays coming at slightly higher price, and hopefully this price also will come down once the Indian market is flourish. This is the third research that you can do, and all these things cannot be a sufficient thing if you want to employ, or if you want to put this particular component into the practical situation or practical application. So what is the drawback? The drawback is that the surface roughness, if you use the India's currently, I am not favoring any company or something. If you take as per today is concerned, Intech Additive from Bangalore is the India's best machine that you can do. And how you can say, sir? You can say because DMG Mori has invested almost all 30% in the company. So for example, a German company is investing on an Indian company. That means that it has some potential that you can think of. So, and second, they have already supplied to IIT Madras. So a premier institute and the first generation premier institute like IIT Madras is procuring with the stringent conditions and other things. That means that they have some worth to watch. Okay, in that aspect. So I think, for example, if you want to procure the machine, so they have one software called Optomec, and this particular software, I know the capabilities of software because I am the part of some other project where Optomec is used. Okay, so I know the capabilities, and this particular software says that that will give you the best surface finish for any particular material. Okay, for example, if you are using Ti6 for example, TI64, AL4V or something if you are using. So you just put it automatically. You can use your own input parameters, or the software, if you purchase, software also gave you some optimum parameters for which what they claim is that if you use the software and if you don't use the software, if you use the software, you will get a good surface finish. That is what they say. And I asked them, what is the best surface roughness that you can get? So the best surface roughness you can get is in the range of 5 to 6 microns. That is the best surface finish that you can get by using a 3D printing machines which are in India. Okay. So that is what. So now my question to you is that this particular 5 to 6 micron surface roughness is acceptable for a particular component. The answer is normally no. So I'm saying this is the minimum surface roughness. Whenever you go to the normal conditions, for example, any of the conditions where there is no this particular software not there, so this will range from more than 10 microns. For example, if you are building, we have also some components with us. So whenever we are measuring the surface roughness ranges from 15 microns to 30 microns. That is the normal range that people are preparing it. Recently, we received one component from the leading world best company, and for the component came for polishing to our lab. Okay, so we started checking. So there are improper or irregular surface finishes. Some locations it is 15 microns, some locations it is 20 microns, some locations it is 24 microns, and so on. Some locations it is 11 microns itself. So what is the importance of today's talk? If you cannot post-process it, 3D printing is just a showcase piece. Just you have purchased it and keep, whenever the visitors comes, oh, this is our 3D printing machine and we have the 3D printing machine. That's all. You cannot put into the practical condition, for which today's presentation is going to help you how to overcome this problem to make your 3D printed component into a practically feasible component. That is what. And I'm very thankful to the DST, SERB, and various other funding agencies which has realized and funding us. And I'm happy to share that last week we have received one funding for this particular 3D printing internal features polishing, not for external features. External features, we have already a project from DST. So SERB we received for internal complex features polishing. That I am not going to talk anyhow. So the post processing of 3D printed complex features, currently what I am talking is purely external features. As I say that our laboratory, Manufacturing Research and Sustainable Laboratory at IIT Tirupati, which is acronym for my name, Mamilla Ravishankar Group, so works into the area of micro machining and nano finishing, which is my bread and butter since 2004. Sustainability manufacturing or sustainable manufacturing, which is my, again, second bread and butter, which gives me a lot of publications by the God grace. This is another area, and most of the people in Tamil Nadu, Kerala, Andhra, and Telangana, Karnataka, South India especially, most of the people works in these areas like development of cutting fluids and other things. So this is one of the familiar areas for most of you people. So third one is bionanomaterials and manufacturing. We at IIT Tirupati have biomanufacturing laboratory. So whatever I am talking today is purely on metals, but I have another area where I try to work on to a big ambition to manufacture artificial organs like artificial kidneys, artificial skin, artificial liver, this type of things, because many part of South India, the major thing is that poor people are exploited by giving lakh rupee or 2 lakhs rupees, and they took the hospital and they transplant the kidney to a rich people, okay, which may not see the try. Whatever we are trying is abroad nations are trying, so and they are partially succeeded. So there is no harm in doing such research. So what we are going to start is that we start with a, and I'm saying that this is just the initial start that we are doing, and what we are manufacturing is we have already biomaterials, we have the polymers and other things. Only thing is that we have to mold towards that application. So how far we successful, we also don't know. But our group works extensively on orthopedics currently. So orthopedics, many people in Tamil Nadu, I'm happy to tell that Tamil Nadu and Kerala is very, very good in terms of orthopedics. For example, if you see Coimbatore, there is one hospital, Ganga Hospital or some. I was there in Bharatiyar University. So at the time I came to know that there is, I came to Bharatiyar University in 2015 or 16. Yeah, I think the name of the hospital is Ganga or something. So additive manufacturing is another area where we extensively work, but you know, but is a very dangerous word in English. Okay, so why it is very dangerous? Very dangerous is, for example, I love you, but you should be a crorepati. So, but is very dangerous. So, additive manufacturing, I work not in the domain of manufacturing a component. That anyhow I am getting from my sophisticated system. But I try to work on to the post-processing. I mean to say, my laboratory will connect between or the laddering between a 3D printed component to a practical application oriented component. That is the ladder that I try to do. Okay, smart manufacturing group. So smart manufacturing group, as I clearly say, that we not only do research publications, we also try to do patents of this technology, and at the same time we are also trying for development of the products that you can come across some of the slides later. Micro nano manufacturing, I'm not going to talk much about other areas because I already consumed 10 minutes in opening the files and other things. So this is one of the technology that we try to do. So for example, if you see here, we are having a magnetorheological fluids. Whenever you apply the magnetic intensity or the magnetic field intensity, and I guess we take a pointer options. For example, if you see here, this is a liquid, and this liquid has randomly oriented carbonyl iron particles and abrasive particles. When you apply a magnetic field, abrasive particles forms in the chains. So this is a smart fluid. Okay, how it is smart? Just I would like to say here, you can see here from this point of view, our experimental point. This is simulations. So for example, if for our experimental point of view, we see the knee implant need to be polished. This knee implant, we have kept a liquid here. Okay, so whenever magnetic field is applied, it is jump from this position to this position and forms a flexible magnetic abrasive brush. If I release that magnetic field, what will happen? Again, it will fall as a droplet. That means that it is comes to its original state. Okay, so many more things are there in this one. So this is magnetorheological fluids which are externally energized. This need external energy to energize. Otherwise, these are all just liquids. So there are liquids which are self-propelled. Those are called polymer rheological fluids, which you can come across. I'm not going to explain this particular slide because there are few slides which are related to this one in the upcoming one. So this has a capability to polish micro to nano scale. I mean to say features, micro features, nano features you cannot polish. So macro to micro features you can do. Second is sustainable manufacturing. I don't know whether the video works. Okay, it is not working. Okay, so anyhow, video is not working. So whenever you do the machining operation, what is the advantage and disadvantage. The basic disadvantage is lot of temperature will be generated. To overcome this lot of temperatures, what will be do? You will be doing cutting fluids. Whenever you use the cutting fluids, as you can see, this has a lot of emissions and the operator is standing here. So these emissions will have a lot of dangerous effects because these are carbon-based or crude petroleumide derived products. That means that whatever the effect that you have on the emissions of petrol, diesel, similar type of things you will have are more than that. Why more than that? Because you are adding a lot of things. For example, what all you will add in cutting fluids? You will add emulsifiers, you will add biocides, you will add high pressure residues, you will add lot of things to make into a cutting fluid. Because in a IC engine, you pour and you will utilize within 3-4 days or 5 days or so. For example, if you are taking a 1 liter petrol or 2 liter petrol, how many days you will get? Maximum to maximum 1 week. But in this case, in the institutes will purchase a can which is a 20 liters of fluid. So the company knows that these people will use for a semester or 2 semesters. So that means that they have to use a lot of preservatives because you are going to add water to it. Whenever you try to add water to it, what will happen? This has a very, very less life and these microorganisms will form. To overcome that, the people try to add biocides, which inhibit the bacterial growth, fungal growth, and other things. So this is one positive things, but on the negative side, those are chemicals. Whenever these chemicals are interacted with petrochemicals of the pure crude oils, what is going to happen? What is going to happen is that you are having a lot of chemical interactions, and when these chemical interactions will interact at high temperatures like machining temperatures, what will happen? It leads to the chemicals which are very, very harmful. For example, your parents will always tell, I don't know how many of you are children, I mean to say BTech and MTech and PhD students. So your parents will say that don't eat outside food. That is a common sentence. So still, what you will do? You go and eat samosa, pakodi, and lot of things, deep fried things. So deep fried science is a very, very complex science because you have oils, you have water, you have some natural products like powders, you have aloo, you have masala, you have many, many things. What will happen? All these are interacting with at slightly higher temperatures in a deep condition, because of which what is going to happen is that it is chemically destroyed. And you may get the taste, but when it goes into your stomach is experiencing an acidic nature of 4 pH. So, for example, if you take the mouth pH is 7.4. Even though you spit on your enemy or anybody, so it won't harm him because your mouth is at natural pH, that is 7 or 7.4. Whenever it comes to the stomach, it is an acidic pH, and you are eating a deep fried things, KFC, very good. Okay, so that's why nowadays, if you can clearly see one of the advertisements of Virat Kohli, so that ITC Emitos or something will come. He clearly states in one of the advertisements that it is not fried. It is something. So it is not fried. Something he will say. It is not done by the oil. That is what you want to say. Nowadays, you can see a equipment called air fryer. Okay, like your potato sticks are there. No, I don't know what those called. Regularly, my family want it, but I always say no. Okay, so what is mean to say, this air fryer and other things, these technologies are coming up because to overcome the interaction effects of the oils. And second thing that you have to notice here is that the production rate of sunflower in India is not that much. But you go to any store, you will get sunflower oil. Any store, you go to DMart, you go to Maya Bazaar. I am telling about Tirupati, you go to Big Bazaar, anywhere, the best selling oil is sunflower oil. Now it is blended oil, many oils are coming. So now I'm saying is that you should think over it and you should eat it before you. That is what. This is not about Ravi Shankar is called for a invited talk and he is taking only technical. No. Maybe my sentence, if it ignites one mind of the listeners, I am happy. Okay. So what I mean to say is that this, what is the bottom line of the story or the bottom line of my presentation, but particularly this particular slide, is that tomorrow, if you go as an engineer to any industry, these emissions will hamper the operator. Operator has to stay for 30 years in the same industry. And if he dies, what will happen to his family? That extrapolation you have to calculate, and it is your primary responsibility not only to get the profits to the company as an engineer, it is also your primary responsibility to protect your subordinates or working staff, for which my request is that you just need to give them a appropriate safety precautionary things like mask, apron and other things. I am not asking more than that, but this can save a person, indirectly a family, and he may have parents also. So that's what is the story about this particular slide. Next. I am very thankful to IIT Madras for choosing this particular topic as a best paper award in 2017. So this particular technology is about machining or micro machining using microorganisms. So what we try to do is we try to take acidothiobacillus ferroxidans. As your name says, it is ferroxidans. It has a lot of oxide molecules of ferrous. So you need to culture it and you need to populate it, and you have to understand the life cycle of it, most importantly. So other way, you can do the photolithography of this surface and you expose the surface, and this surface you can keep inside and you can get a beautiful micro features that are exposed during the photolithography. For example, you can see here micro nozzle and micro mixture. So these are the beautiful structures that are formed as per the mechanical engineering or a micro manufacturing engineer. I'm happy about it, but I can also do the same thing by micro lasers and other things. But in that circumstances, you will have thermally destroyed layers or thermally modified layers. One. Second thing is your material will evaporate because the material removal mechanism is melting and evaporation. So what is the second advantage of this one is you can take the copper nanoparticles. You can see here how the copper nanoparticles, these are the organisms and these are the copper nanoparticles. And since our workpiece is a pure copper, and whatever the particles that we are getting is copper nanoparticles of good purity. However, if some oxidation is there, you can do some reduction reactions and you can get the good purity. Now, what is the second advantage of it? The second advantage is in the market, if you go, the copper nanoparticles are so expensive. And I'm hinting you, if you can make a startup company, if you can make a pure to purest copper nanoparticles from a copper sheets, your company in next 5 years or 7 years will cross minimum to minimum 1 crore turnover. Only thing is that you need to develop that particular technology where you can convert copper to the copper nanoparticles. If you can convert, that should be a big company. Okay, so now we are coming into our business. So this business is all about additive manufacturing. So additive manufacturing group works into various areas, and you can clearly see what is additive manufacturing is all about. Additive manufacturing is all about is conversion of any particular component that you are seeing here to this particular thing. If you can convert, that is, you can use into the practical application. If you cannot convert, you cannot use into the practical condition. So how to convert this to this, and this can be done by not a single process. You have to do multiple processes. What are the multiple processes? Basic additive manufacturing, we have powder bed system, direct metal deposition system, and we have the system with wire arc additive manufacturing and other things. Okay. Now you can see here selective laser melting and selective laser sintering. So many people get doubt, including me also. What is the selective laser melting? What is selective laser sintering? If you go and Google it, because whenever you get doubt, the first and foremost thing that anybody can do is Google. The first difference that you will get is selective laser melting is for metals. Selective laser sintering is for polymers, because nowadays polymer particle bed type of thing also are coming. Okay. At this point of time, I also would like to tell you another hint about additive manufacturing. If your institute or if you are going to purchase a 3D metal printer, I already said you wait for 1 year. If you can wait for another 1 year, you will get a universal type of additive manufacturing. What do you mean by universal type? I cannot say universal type or something. Just it is my way of expression. What do you mean by that? What do you mean by that is the same system can do polymers, same system can do metals, same system can do ceramics also. This can be possible by one of the latest technology that people are now coming up, that is called binder jet 3D printing. Binder jet 3D printing is whatever the particles that you have in your bed, you just have instead of laser on this system, you will have a binder, suitable binder. For example, if I have a titanium alloy, suitable binder, I am going to inject. If I have a polymer, suitable binder. Only thing is that the binder is going to change. So that means that those people who are interested, so they can, that system is also not expensive. Currently, there were multiple systems by 3D systems, 260 series, 360 series, 460 series, and 660 series, and 560, lot of series are there. So now they have only 660 series. They don't have because research institutions are not purchasing these lower versions. All industries want higher versions. That's why they have only a top version series. So 660 or 560. That will cost you like minimum to minimum 60 lakhs or something. 60 to 75 lakhs. Okay. So this another suggestion that I want to give you is, if your institute need not to pay multiple crores of rupees for metal 3D printer, you can get a metal binder. There is another company now it is coming up is Desktop Metal. There are other companies, many companies like HP. You all know our printers and other things. These people are coming up. Only thing is that it will take some time, for which just wait and watch the market. Wait and watch. So direct energy deposition or direct metal deposition is another variety. So why I want to show this particular thing? If you can see here the surface, direct metal deposition technology. Direct metal deposition technology, this particular technology will give you a minimum surface roughness above 20 microns. The starting value itself is 20 microns. Now you can imagine, you can clearly say that this particular component cannot be used in practical application until and unless it is post-processed. Okay. So these are the various additive manufacturing which you already know. What you might be not knowing is this particular technology, direct metal deposition technology we will use. This particular technology we also use, if you can clearly see here, for bimetallic parts. Okay. Bronze on steel. So this type of things we are doing. As you can see here, whatever our students has deposited here. So H13, tungsten, niobium, these type of things, and later. And currently what we have the component is, this is bimetallic components. So bimetallic components you can also do by WAM, wire arc additive manufacturing. At this particular junction of time, wire arc additive manufacturing is widely used for large components. Forget about large components. You are sitting in a private engineering college. How you can do? I was surprised to see one faculty in Andhra Pradesh. Okay, he is sitting in a private engineering college. Just I'm saying, this particular year, he sent me a message, I think 5 days back. Sir, this year I published 14 SCI publications with a top impact factor of 11. I asked him, very good. So what he has done is, he is doing on additive manufacturing, simple welding lab, he converted into a wire arc additive manufacturing. So now you people who are all listening from any state, I don't bother any state or something, it is open to you. You can convert your laser arc based system into a 3D printing system. Only thing is that you have your hand, you can build on top of it, or you just have a rotary system and reciprocation system. These systems won't cost you much, like more than 50,000 rupees or something. Hallmark is there. You just get a XY stage from Hallmark. If your accuracies are not that much, you will get for 70,000, 80,000 also. Then you have already arc welding torches. So you just put and reciprocate your bed or something by fixing your welding torch. So you can deposit the layer by layer. That is what other persons are doing. You can also do this particular additive manufacturing of WAM. WAM means wire arc additive manufacturing process. Or if you have 2 torches, you can do 2 materials, bimetallic. If you have 3 torches, you can do trimetallic. So this is very easy for you to do, but deposition, microstructure, residual stress analysis, and other things you can measure and you can get a paper. There's no problem. But here, another problem is that you cannot use that component into practical application. That is a different story. Just I'm telling you, as I can say here, this is the surface you will get. This type of surface you will get. But I mean to say, compared to this is a direct metal deposition, you will get still more higher roughness you will get. Like normally in WAM, the roughness values will be in mm, like 3 mm, 5 mm, like that. Because we regularly do that. Machining of additive manufactured WAM components, which are done by our colleagues. Now, primary post-processing of additive manufacturing. So, in polymers, most important thing is that you need to remove the support structures. Or in metals, you need to dismantle your component from the base plate. So that is another way of technology. For example, if you have built on a build platform, a temporary build platform, you need to take out that. So how do you take out? How do you take out is one of the famous processes that you have and we have is wire EDM process. those people who want to work on Viridium or something, we at IIT Tirupati have a 5-axis Viridium. If you have any complex features to be machined using Viridium, you can come. We have this particular system from Charmilis, Agile Charmilis, Switzerland. Our worth of the machine is more than ₹1 crore. So you people are most welcome. As you can see here, how the component is dismantled. For example, you can see my cursor. This is the Viridium and wire. And most importantly, what you can get is our wires are so precise, like 250 microns. And these are stratified wires. Stratified means you have a sacrifice layer on the top of it to make the component dismantling or to cut a particular component into a perfectly shaped component. The second thing that we try to do is machining of 3D printed surfaces. Okay, so we not only work on machining of 3D printed surface by lasers, we also work on electron beam. We also work on plasma beam, additive manufactured features and other things. We are very thankful for all the collaborators across the globe. Okay, we have the collaborators, as you might have seen my webpage. If you have not seen, just you can go and see. So you can, we have the people from Japan, we have the people from Europe, we have the people from America, and so on. So we are thankful for all the people who are part and parcel of it. And most importantly, our collaborators are our students who graduate from my lab and other laboratories of the institute. So Viridium and mechanical type of machining. These are the two big things that you require at the starting of any particular component to be post-processed. Okay. The second, once you dismantle it, the surface roughness, if you can see here, it is very, very rough. So now how to overcome is. So if you take the surface roughness here, the surface roughness levels will be approximately, as per my understanding, which I see, I have a bad habit. By seeing since the 2002, I am working in surface finish. By seeing the surface finish itself, I can say tentatively how much it will be there. But sometimes I'm right, sometimes I may be wrong. That's it, okay. Here in this particular system, so I expect, or you can also clearly expect, it will be more than 20 to 30 microns. Okay, how to use into practical application? So you cannot use. For example, if you take lattice structures. So how do you polish the lattice structures? Lattice structures, very, very complex to polish. Okay, so till now, there are no good technologies that came up to polish this lattice structures and other things. Okay. So those people, if you can find okay, so now you can see here, I was just taking some tea. Okay, so the drawback of 3D printed surface, now you can do the machining as well as Viridium. That much you have done. Suppose another option for you is, if your institute is well-rich company or well and rich one. So in Tamil Nadu, there are big, rich institutions are there. You can go for DMG Mori Hybrid Machining Center, where you can see here, you can deposit by using direct energy deposition system. At the same time, same machine, you can also do this machining operations also. So this is called Hybrid Machining Center. But the price of this particular machine is, starting range is 7.5 crores. Okay, that's why I said, if your institute is rich enough, you are most welcome to go for this particular process. Now, surface finishing technologies. We have surface finishing technologies like abrasive finishing technologies and abrasive-less finishing technologies. Okay, so These are the common post-processing technologies that one uses in the industry in India. First, they will go and blast with the sand blast or bead blasting and other things. Second one is, if there is some corrections need to be done in a large surfaces, they can go for hand polishing, for example, hand grinder and other things. If you have some features, internal features, which are not accessible by these things, they will go for ultrasonic polishing and other things. If you still have in such some of the problems and other things, you can go for, finally, you can go for electrochemical polishing or chemical polishing. Normally, chemical polishing will be first, followed by electrochemical polishing. Okay. Now, these are the standard protocols that Indian industry will do. So what are the abrasive lists? And what are the industries are doing? I don't know about Coimbatore is a very good industrial city. So where you can find this type of technologies like chemical polishing of structures. There is a chemical, electrochemical, anodizing plants and other things. These are the common technologies that people uses for finishing of normal components as well as additive manufactured component. This is the after and this before, you can see here. How do you do? Normally what we try to do is we just put a tape here and we try to dip. So because of which what we can do is you can differentiate the surfaces. At the same time, you can, if you have two components, you can do differentiate like this, or you can see the knee implant like this. So there is one startup industry in IIT Bombay, which is BITEC, BITEC, okay. So which is headed by Professor B. Ravi. So they do on these implants manufacturing and other things. You have, if you want any institute to get that center, I don't know whether they will give to a private institute or not. I'm not sure. So recently when I was discussing with professors, says that if you want a center at IIT Tirupati, do let me know, like that he was there. So they will help you people to give some of the technologies which you can explore those technologies around you to open a startup company and other things. That is what I can pass on the information. Lattice structures. Lattice structures are normally polished by chemical polishing or electrochemical polishing only, because these are very, very complicated in nature. For example, if you see, these are the surfaces, and these surfaces are 3D printed like this. And if you see after the polishing, it will look like this. These are very complex, and India currently we don't have such technologies for polishing or lattice structures. If you have external surfaces, it is very easy to do the polishing and other things. Laser polishing is another area where we extensively work, because laser polishing technology, currently we are also procuring some of the lasers, multiple lasers, not a single laser. Some lasers are good for, because whenever you do laser polishing, it is laser remelting only. You have already a laser melted surface. 3D printing component means it is a laser melted surface, selective laser melting. So on top of it, if you do again laser, so what is there? Already you have taken a dip in Ganga. If you want to take a second dip, what is the problem? The first dip itself is a problem. You will get cold, like that. So in the second dip, what is the problem? Already you have taken a dip, you take second dip or third dip, what not a problem. So already it is done by laser. So, and normally the laser that you will use in the selective laser melting is in the range of 400 watts to 700 watts. Sometimes it goes to 1000 watts also. Sometimes it goes to multiple laser sources also. So what you will use here, as per our systems are concerned, is that we try to use a maximum to maximum of 100 watts, if not 200 watts is the maximum. Why we are using? Why we are using is, it is contact free and eco-friendly. Eco-friendly is a relative statement. whenever you interact with laser with respect to any material, there will be some fumes, definitely. Compared to electrochemical and chemical, this is slightly better. The basic drawback of electrochemical polishing system or chemical polishing system is that if you are putting in your laboratory, it will emit a lot of emissions, and those emissions will destroy your surrounding equipment. So electrochemical process or chemical processes, you should discard those things to another room or somewhere where the emissions are exhausted properly and other things. Otherwise, it will be very, very. So that's why I'm saying always laser or anything is relative statement, eco-friendly and other things. Because when compared to other technologies, this is eco-friendly. But as I said again, but is dangerous. But there are some emissions. Less time consuming, accurate, because laser, as you know, it is accurately controlled and not depend on chemicals and materials, because there is no chemical and materials, and flexible and can be used. You can do the fully automatic. Okay. There are two systems that we are procuring. One is for laser polishing, another one is laser shot peening and other things, because you can do the polishing by that technology also. As you can see, the mechanism works how. So laser smoothing effect, you can see here, laser smoothing effect is purely you are doing a remelting. Already molten region is there, you are just concentrating on the peaks and you do the material remelting. So there are various input parameters that you can do. So laser power is primary parameter. How much power? As I was clearly stating in the previous slide, that the power utilized for laser melting process or selective laser melting process is 400 to 700 degrees or 800 degrees. You can, 400 watts to 700 watts. So on an average, you can take just to take 550 or 600 watts is required. But here you require only 100 watts because you are concentrating on the peaks where surface area is very less. So you can melt those things and you can deposit those rays. There, how the mechanism works? The mechanism works is melting and evaporation. So as the Gaussian beam distribution is there in the lasers, what you can do is the central portion will evaporate and side portions will melt and occupy the valleys. So the first is power. Second is scanning velocity. If your scanning velocity is too high, what will happen? Partial melting will take place and fall into the valleys. So you should have appropriate scanning velocity. Laser beam diameter. So laser beam diameter, in particularly for polishing, you can see here, in laser beam melting or selective laser beam melting process, you concentrate a point because you need accurately built component. Here, you don't want that because you want to concentrate on a particular surface. So you can go for defocusing of it. Defocusing has two terminologies. One is positive defocusing, another one is negative defocusing. Positive defocusing, if you can do, that means that the positive defocusing is after your focal point. So if you can increase the distance, nozzle tip distance, whatever you call in EDM process or another process, inter-electrode distance. So what will happen? This will diverge. That is called positive defocusing. If you are bringing your workpiece before the focal point, that is called negative defocusing. In both circumstances, you are going to get a laser beam circle. I mean to say, you are distributing your point high temperature into a uniform low temperature surface. That means that whatever, for example, if I am using 500 watts, for example, polishing, I am using 100 watts. 100 watts will have a peak power at the spot wherever the focal point is there. If you are moving up what you are going, you instead of point, you are getting a circle. That means that your 100 watts is dividing from a point to a circle. That means that the interacting temperature will be less, which is you want. So you can play with respect to laser beam diameter. And normally laser beam diameter will be specified by the focal point only. That is 200 spot size. For example, what we are getting is a 50 microns diameter. Okay. So track offset, track width, pulse duration, repetition, and other things. And whatever you have here not mentioned is that focal point. You can also vary the focal point. And some people are working on to the angle of incidence. Why they do angle of incidence is because of the Gaussian beam distribution. If the Gaussian beam distribution, if you see, it looks like a 6 sigma curve. So at the center, it will be very peak, and at the edges, it will be very less. That means that you don't get proper melting and evaporation on the both sides of your 6 sigma curve or a Gaussian beam distribution, for which what they try to do is, so this Gaussian beam distribution, the central portion is again and again can be done onto these layers. Now you can see here, we have tried on laser polishing of not metals. We want to do on ceramics. So that's why we tried to do on ceramics like silicon carbide and other things. These are the applications. Once you understand science and other things, you can do a lot of things and lot of polishings. These are abrasive-less polishing techniques such as electrochemical polishing, laser polishing, and so on, chemical polishing, so on. As you can clearly see here, unfinished layer by layer deposition, and here the finished. Okay, so these are the applications of it. Now we are moving into the abrasive-based post-processing technologies. So these are the complex features, internal features, and other things. So the first and foremost thing that you can do with abrasive is blasting or mass finishing operations like sand blasting, drag finishing, and other things. So we have at IIT Tirupati drag finishing system, which is yet to be installed, which came almost all 3 to 4 months back. Because of scarcity of the space, we have not installed. Now, this is called bead blasting or sand blasting, where you, okay, so you can remove those particular particles by blasting, or you can also remove some of the supporting structures by these blastings. As you can see here, the components are done internal surfaces and other things under a controlled environmental or a closed loop system like glove box and other things. So as you may be well aware that the surface roughness in the abrasive, I mean to say additive manufacturing, is very, very rough. So sometimes it is advantageous. Okay, so now you have to find those areas where it is advantageous. One of the applications is acetabular socket. For hip implant applications, it is very, very useful because you require osteoconductivity and osteointegration onto the top surface of your acetabular socket. That you can clearly see here. See, your acetabular socket is here, and this particular surface need to be very, very rough. And because this should be a biomaterial, and this will go and stick onto the top side of your hip implant. So that's why osteoconductivity, osteointegration will take place. So the second process that you can see is vibratory bowl finishing, where you have a lot of abrasive particles are there, and you just rotate it. So whatever you rotate it, automatically what will happen? It will experience the finishing and it will do the finishing operation. Okay. The other processes is you can also go for belt grinding process and this type of drag finishing process. Drag finishing processes is one of the widely used process in terms of 3D printing components, in terms of any type of batch and mass productions. You can use. The basic drawback in the previous system is that, for example, in the system, all you are dumping into a bowl and you are rotating it. There is a chance of component to component interaction. But in this case, if you can see, all the components are fixed. So there is no chance of this hitting to the one component to another component, and deformation problems will not be there. That's why people prefer drag finishing. And as I said, Coimbatore is an industrial place. Many companies also produce this type of drag finishing systems. So at the same time, additive manufactured features or implants can be done by belt grinding process and other processes also, as you can see here. Okay, so there are multiple things that one must need to understand here is interaction forces. For example, if you see here, this bottom two, if you see here, so interaction forces are very high because the material removal is very high. That's why you are seeing a lot of fire type of things, spark and other things. But if you see here, this is a cloth grinding process where you don't find. So interaction forces is always depends on what type of material you are using. Here it is a very solid one. Here it may be a rubber wheel or it may be a sponge type of wheel where you have abrasive particles are put into a liquid mode or something. That's why you can see there is a lot of deformation and other things. From this, what you can understand is that if you can convert from solid to a liquid or a semi-solid or a nearly porous solid, you can have less interaction forces or something. So the same technology we can have took forward, and you can see here we have developed one of the system called abrasive flow finishing system. This system has three elements. One is the machine tool experimental setup itself. Second one is fixture. So for example, in this case, a cylinder is there. Two flange type of fixtures are there. So the flange type of fixtures or any type of fixtures or tooling, the function is to hold the component in place firmly. Second, to guide the medium to flow across the component to be polished. And the third and most important is the medium. Recently, 1 year back, we have received a patent on this medium and we are filing another patents in this area. Okay, so we have multiple varieties. The commercially available mediums are 3 only. So in our case, we have almost all 6 to 7 varieties of mediums are there. So those people who are interested, so there is one company in Coimbatore which is regularly asking us for this particular technology to give to them. Because of some of the technical and non-technical issues, we are still unable to process, but I'm sorry, Srinivasan ji. So we have to go a long way to develop this particular system. Currently, we are in the level of TRL 8 actually. So whenever we want to give this particular technology to any company, we wish to make sure that we don't want to come back again. Whenever we want to launch in a full-fledged manner. So for that, what we want is we want to make ourselves TRL 10. So once we are at TRL 10, we want to launch it. That is what the reason that I have conveyed, and he was also happy about it. Thank you. So this particular technology is a simple way. I cannot tell you the complete into the how a liquid works. For example, I have this particular liquid, which is a semi-solid type of liquid. Whenever I am applying extrusion pressure, you have particles here, and these particles are functionalized basically. These abrasive particles, for example, diamond abrasive particles are functionalized such a way that your polymer networks holds it. So what is this polymer networks is all about? This polymer networks is all about is a viscoelastic polymers, and whenever you apply a shear force in this direction, what it will do, it has a viscous and elastic component. Elastic component tries to move in perpendicular direction. Viscous component tries to move in the direction. How do you know? How I know? For example, if you take a water or honey or anything into your hand and throw it, okay? So what will happen? It will flow along the direction of what you have applied pressure. That is called viscous effect. Second, elastic effect. You take an eraser. You have many have people are married and children are there. So just take a eraser and try to press with your thumb. What will happen? It will try to move perpendicular direction. It also try to move in the direction of applied pressure, because your eraser is not purely elastic. It is elastically dominating viscoelastic material. So it will try to deform or extend into the perpendicular direction. That's why the radial force will come. Now, this particular technology you take into here, you have an abrasive particle. Abrasive particle is supported by your polymer networks, which is having the characteristics of viscous and elastic nature. Whenever you are applying extrusion pressure in this direction, you have axial force and axial velocity. And because of the elastic component, you have radial force and radial velocity. But indentation velocity is much, much less compared to your axial velocity. That's why normally they don't consider the radial velocity. So this is about the materials, but these are the 2003-2004 materials which we have patented already. That's why we are showing you. So this nowadays people are not accepting these things. However, we have moved to latest materials which I cannot disclose at this point of time. So, but the characteristics of this flows like a fluid, jumps like an elastic ball, breaks like a plastic piece, and other things. Because of this, what is the uniqueness is flow and deformation characteristics are very complicated in nature, for which you have to do rheological characterization. The rheological characterization, for example, the first and foremost characterization is flow studies. How it behaves in the while it is flowing. The flow behavioral study. Okay. So, for example, if you take any curve, all the curves are following across the x-axis. If you take shear rate, so it will have all similar trend. For example, you take a pink one. So what is happening as the shear increases? What is gradually your shear stress also increases. That means that your polymer molecular chains are climbing one over each other, because of which unity comes into play, because of which it is increasing, and anything has its own limitation beyond which it will break. So polymer networks starts breaking and align in the direction of motion. That's why you can see a decrement in this region. So second, if you can see here, plasticizer amount from y-axis stress, green to pink, it is decreasing. But green to pink, if you check, it is increasing in terms of plasticizer. What is the science behind it? The science behind it is you have elastically dominating viscoelastic materials or purely elastic polymers. Nothing in this world is perfectly elastic or something. So you have dominance of elastic characteristics, because your polymer networks are near to each other. So interpolymer molecular distance is less. So the force of attraction between two polymer molecular chains is very high. So whenever you try to add the plasticizer is a low molecular weight material and polymer is a high molecular weight material. When you add or blend or mix a low molecular weight material, this low molecular weight materials goes and sit in between two high polymer molecular chains and try to kick apart. That means that the distance between two polymer molecular chains is going to increase indirectly. The force of attraction between two polymer molecular chains is going to decrease. So as you increase as per your requirement, the distance between two polymer molecular chains will increase, and the force of attraction or cohesiveness will decrease. Why I have to do this? Because your material is an elastically dominating material and I want to make it as a viscoelastic, for which I have to blend the elastic characteristics. That is as simple as. But if you directly add it, it won't go. That is where the trick is. That is where the companies work. So you need to use a lot of functionalizers. You need to use a lot of rheological additives and other things. So that is where the bread and butter of the companies and patent technologies, which you don't find in the patents. Normally, you will find the patents like plasticizer, polymer, and other things. So you may be getting doubt, always viscoelastic and other things. Whenever you talk about viscoelastic, how to measure the viscous component is a big question, for which whatever normally you can see on the time domain you have and frequency domain you are having clip compliance. That means that you are putting some stress and observing some strain. Now, $1 million question to ask here is that what is the stress that I have to apply? For which you have to do the dynamic rheology, where you can change the shear stress and observe the storage modulus. So whenever you are observing, there is the one region where there is no change in the storage modulus. That means that my polymer molecular chains are at original state. Now, if I can use anything in this range is called linear viscoelastic range, beyond which you can see the non-linearity, and this non-linearity is because of the polymer stretching or polymer breakdowns. So now if I can take any particular value where the storage modulus is approximately same, that means that my polymer molecular chains are at original state. So neither it is broken nor it is stretched. If I can take any particular value in this range and I can put it to the viscoelastic range, and I am putting 100 Pascal here, A to B is viscous and elastic, and B to C is that elastic. So now you can calculate what is the viscous component, what is the elastic component. So now you can use for percentage how we want to show or we want to observe how elastic dominating medium and viscous dominating medium works. In this case, if you take a 35% of viscous, that means a 65 of elastic. So elastic, as I said, radial force will be very dominating. Not only polishing, it is also creates its own shearing marks. That is what happened here. As you increase your viscous component, you will get certain position, better characteristics, and you can get the finishing. Beyond which, if you go, what will happen? It will just simply slide, not the abrasion or good abrasion will takes. Okay. So now once you understand the science, you can see your impellers, turbines, and other things can be polished clearly. Only thing is that you need to play with respect to the medium, which type of medium you require. Here, the component size is very big, so you can go for high viscous medium, and you have to design your fixturing accordingly. So now 3D printed components, as you can see here, 3D printed components before finishing and after finishing, how this look like. Only thing is that you have to have the recipe. If you have wheat flour, you can make chapati, puri, dosa, parota, anything. Okay, samosa also you can make. Only thing is that whether you have that wheat flour or not. Okay, so these are the large structure components polished by extrude hone companies. And you know what is the charge? The charge of this particular finishing goes beyond 10 lakhs. Okay, because the medium cost that will come from US, I'm not talking about my medium. Why we have developed this medium is in the market, this particular medium, 2 kgs is ranging from 3 lakhs to 5 lakhs, depend on your requirement, depend on what type of abrasives that you want. If you are going for diamond particles, it may be very, very expensive, like 5 lakhs rupees, 2 kgs. For your system, you require minimum 10 to 15 kgs. That means that one run, if you want to make this particular system, 5 lakhs into 7 times or 6 times. Okay, so it will be minimum to minimum. You will charge, medium charge itself is 20 to 25 lakhs. So that is the patented technology that we have done. And this, as I said, Rome is not built in a day. So this fort, I can say Satavahana fort or any fort, which we have built from 1926 onwards. Now we are in a position to commercialize. As I said, still we are having some repeatability things. Those things are to be done by doing extensively thousands and thousands of experiments to provide what are the input conditions to the industry. Because industry, they say, we don't have time. We want to press a button, we want output, that's all. So that level, we are making it into a smart system. As you can see here, we try to make a smart system. As I said, we work on to the PPP mode, publications, patents, and products. So this is our first product that we are working in a HMI system, that is human machine interface system and other things. Okay. So this is the technology that we have already given to one of the leading research laboratories such as CMTI Bangalore, and this is already working fine. So this will give us feedback, and we have our own system will give the feedback. So these feedbacks we are going to take, and we are going to come up with a very solid system in future. Thank you one and all for all your patience, and as already introduction says that I am a guest editor and other things, and I'm going to be a guest editor for one of the SCI Index journal that I will come back to you in couple of months or something. Thank you, and I am acknowledging all the funding agencies ranging from 5 lakhs to 60 crores to 120 crores. Okay, so this is about the funding, various imprint like 6 crores and other things. And I am happy to share that last week I received another 40 lakhs funding from another funding agency, and one of the postdoc and other things. We are looking forward for some of the projects which are under pipeline. Yeah. So at the same time, I'm very thankful for many of the students. If you can see here, I have many students from NIT Trichy and Anna University Guindy. So who started their career under me as a summer intern. One student is there. I think he is from Trichy. Trichy? No. Rajkumar. K. Rajkumar. Some Rajkumar. He did from his BTech from production engineer, Anna University Guindy. He came to me when I was in Guwahati in 2014, as I guess. And with 2 months of time, he has put very hard work, and he has published 3 publications after he had done a lot of work, then went back to the university and he published 3 publications, and he went University Cincinnati for masters. Then currently he is in Cargamilan doing his PhD. I think he is on the completed stage or something. So we are open for dedicated and hardworking students who can come up. At the same time, we are also open for winter internship, which is going to be online. Okay. So those people who are interested, they can start their winter internship and they can pursue their summer internship, because once you come here and if you do start doing literature survey and other things, you cannot do experiments or something. Okay. So what the students currently who are working with me, because I just want to tell you, because some may be students here. So you can do literature survey and other things as per our requirements and are as per our common interest, your interest or your supervisor and our group interest. So you can come up with the literature. Once you come here, you can spend 1 week on finalizing your literature and you can start your work, experimental work or modeling work. So those people who are interested to join our group, you can write a mail to us, but make sure that you are going to work in an IIT. So you should, at least if we expect hard work from you. Okay, sincerity and honesty. Whenever my supervisor always tell, these 3 things are there, must: honesty, sincerity and hard work. If you can do, you are the boss. Thank you one and all for your kind patience, and if you have any queries and suggestions and comments, I'm happy to take up. Thank you.
Molly, madam. Molly, madam.
Yes, sir. Any queries, sir? Any queries from anybody, sir?
Sir, I have one query.
Yeah, please. You can introduce, please, because I am new to the South India, so I was in Guwahati previously, so I don't have much connections. If you introduce, that will be great, so that I can understand, okay, that institute is working in this area. Like,
Sir, I'm Dr. Ganesha Balamurugan from IFCT Green College.
okay, you are the same guy who called me.
Yes, sir.
Yeah. Please, Ganeshan ji, please go ahead.
Sir, what is the scope of the surface engineering research in future?
Surface engineering in?
Surface means what is the coatings and the surface improvement of the surface roughness, that type of research.
That is what I said. No, that has a lot of scope in additive manufacturing. Additive manufacturing, people are saying, I am making a component. For example, this is there. I am making a component out of it, and I am making it. I don't have additive manufactured component. Just if it is there, I'll just show you. Because a lot of components comes to us for polishing applications. Okay. You see, we received some of the ceramic components for polishing applications. Okay, I don't know. Can you see here? I cannot show this component. Just I will show you what I will put you. Okay, these are the components that are coming for polishing applications. So polishing applications has a huge, but only thing is that how do you polish it? That is a question. Okay, so the polishing solutions, there are many solutions. And what solutions? These solutions are very expensive. That is the only thing. So if your question, there is a lot of scope. Answer is lot of scope is there. But it incurs a lot of amount also. Only thing is that how do you strike your balance there? That is the only thing. If you want me to elaborate any particular point, I can elaborate.
Okay, understood the difficulties because of the funding difficulties.
Money you require. As I said, no, we have almost all currently 3 to 4 crores in the area of polishing. So we are almost all in our lab. We have more than 10 varieties of polishing of 3D printing. 10 varieties. So I said that incurs 4 crores minimum.
So that is a difficulty for the private institutions like us.
But you can collaborate and work, not a problem. So that's what, see, I have my own drawbacks where you can satisfy me. For example, see, I collaborate currently, as I said, I don't have a 3D printing machine now. I mean to say SLM, I don't have, or EOS, I don't have. So that is tendered in my institute, and it is going to become effectively by next summer. So till then I have to depend on somebody. So now I have to find a person who can do for me that and who has a requirement of polishing. So both we can connect and we can grow each other. So win-win situation for both of us.
Understood, sir. Thank you.
So if there is any questions from any audience, please. Hope you like the session. I don't know how many of you like, because
So I think there are no more queries. So thank you very much, sir, for your elaborate and educative lecture. We cherish your association. This institution has been calling you. We still remember, Green, the last delivery of your lecture on cyber physical manufacturing.
yeah,
And in this 3D printing also, apart from making the product, forming the product by printing, you extended your lecture on finishing technologies also, hybrid technologies. And your lecture was punctuated with similes and metaphors like taking a safe dip in Ganga up to using a eraser from a schoolgoer. That was very nice. We enjoyed your session. And we thank you very much for working on a holiday for us. Thank you very much, sir.
yeah, thank you. Because I committed, so I have to come to the office. Because so now convincing wife on a holiday is very difficult.
Sure.
Because having a 1-year child, where nowadays is a nuclear families, so wife and husband and kid. So convincing on Saturdays with 1 year kid is always difficult. But anyhow, he said, I have committed, I have to go. So anyhow, it's okay. It's always, and I have a good association. Always I cherish with your institute, professor, because you are the one of the institute whom I connected in Tamil Nadu after my journey at IIT Tirupati. So I have a, I can say there is some special place or something you can say. Yeah. So
Thank you very much, sir. We look
always,
forward for the continued association, sir. Thank you.
definitely, professor. Definitely, whatever the support that I can extend, I can. And if you want any of your student want to do summer internship or winter internship, but only request from my side is not take more people, but I can take 1 or 2 people from each institute who are the toppers. That is the only my request. And other audience also, if you have any students, good students who can do hard work, those who want to come in the summer, they can start their work now. Winter internship, that is called winter internship, where it will go for 1 month, where they can do some of the literature aspects. It is not that you have a 2 months of summer internship and they come and they complete their internship in expert literature itself. That may not be good. So because they when they come to IIT, they want some practical experience of these machines that we have, which are sophisticated enough. For example, we have a laser micro manufacturing system is there, where we can do coatings, where we can do machining, where we can do texturing, where we can do polishing, all those things. It is a 1.8 crore machine. So, and for example, we are getting one machine called PPMS, but we may not allow the people to do. So that particular machine cost, it is beyond your imagination. It is 18 crores. Okay. So for example, if you take so at least the people will have an exposure of the, for example, you have in IIT Madras also. So in IIT Tirupati also, we are getting HRTM, for example, simple, another common equipment that HRTM, high resolution transmission and microscopy, which may not be possible in your institute because the cost of the equipment is minimum to minimum is 10 crores, minimum. So those things, when they go, they will understand practically. If they are not allowed to operate, obviously. They will see what it is. So whenever they go with the sample, brother, I want to do this sample. So they will do in the presence of them. They will understand what is the grain boundary, how transmission electron microscopy works. For example, they go to PPMS, they will understand the physics and other things. So in that way, people get some exposure practically. That is what my way of. So if anybody want, you can please approach. And this is for 1 month. From the date of joining, 1 month winter internship will be there. Who is interested, they have to come through proper channel, through the supervisor or anybody. And we don't have any problem in giving authorship to any private engineering college also, subjected to your technical contribution. At least you should have some technical contribution along with your student. We are more than happy to collaborate and more than happy to give you authorship also to the student as well as the concerned faculty also. Thank you.
Thank you, sir.
That
Thank
was
you
so
for your
nice of
question.
you, sir. So whether this thing is open to pre-final years to UG students, sir?
Yes. So they can come for their pre-final year, means the third year, no? So they are, they are the most eligible people. So those people who completed their 6th semester, now they will do summer internship and no. 5th semester, they might have completed 5th semester now. So 5th semester people, they can start doing summer internship. After 6th semester, winter internship, and after 6th semester, they will do summer internship for 2 months or whatever your guidelines are there.
Yes, sir. Yes, sir. Thank you so much, sir.
After 5th semester, I mean say second year completed, third year entrance, they will do some winter internship because it comes in December, January. So they may start normally people, some of the people who are doing under me is starting in the December first week to the January first week they will do. So otherwise, if some people nowadays are starting on December 15th to January 15th like that. So they will do 1 year rigorous literature and they will come back to me in the summer for doing the experimentation corresponding to that. Okay, so some students they are most welcome. Yeah, thank you. And we are also open for the MTech and PhD students who want to do their partial experimentation, not full, partial experimentation in the range of what we have. For example, laser or additive or polishing or any other things. Suppose, for example, they are working under you for additive manufacturing or 3D printing, they can do, and they can do all the things there, and they can come here and they can do the polishing, and it can be a good thesis. So because it's a partial experimentation they are doing for making a final product. Printing, material development, printing, machining, also partial they can do, polishing they can do, and final product. So partial experimentation they can do IIT Tirupati. Yeah, that's also possible. Subjected to through proper channel, they have to come. They have to write a mail and they can come to us. Yeah.
Yes, sir. Thank you so much, sir.